video, we are going to explain about the project title Satellite Image Classification with the Deep Learning. Despite substantial advances in global human well-being, the world continues to experience humanitarian crises and natural disasters. Long-term and also reignited conflicts affects peoples in many parts of the world, but often accurate maps of the affected regions either does not exist or are outdated by disaster or conflict. Satellite images is regions readily available to humanitarian organizations, but translating images into maps is an intensive effort. Today, maps are produced by specialized organizations or in volunteer events such as mapathons, where imaginary is annotated with the roads, buildings, farms, rivers, etc. In this project, we are going to explore how machine learning can help pave the way for automatic analysis of satellite images to generate relevant and real-time maps. Additional of this application of the state of the art results in the deep learning has been increasingly accessible to various different domains over the past years. Main reasons being the advent of end-to-end approaches in deep learning and the access to vast amounts of openly available data and high performance and compute. The same does, however, not hold true for the research community invested in interesting in satellites, imaginary, and also remote sensing, while accessing the high performance compute infrastructure has not been an inherent factor. The main objective of this paper, by using deep learning convolution neural network algorithm to classify the satellite images such as airport, agricultural lands, forest lands, etc. By using different algorithms to train CNN algorithm based upon the IARPA functional maps of the world dataset. Hardware requirements: we need operating system Windows, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. Software requirements: we need to install Python with a version of 3.7. Methodologies: to implement this project, we have designed a few modules that are: first one, upload satellite dataset. In this module, we are going to upload the dataset to this application. Second one, extract features from the images. In this module, we are going to extract the features, read the images, and also normalize the images and reshape the images and split the dataset into train and testing part. Train dataset consists of 80% of the dataset to this application and 20% of the dataset contains of the dataset of application. Now next module, train CNN algorithm. Using this model, we are going to train the algorithm based upon the CNN algorithm and build the algorithm of CNN algorithm and test the algorithm by importing the test data to get the calculated accuracy, precision and recall and F1 score. Next module, accuracy graph. In this module, we are going to plot the graphical representation of accuracy, loss and accuracy graph by using CNN algorithm. Last module, upload test image and classify. In this module, we are going to upload the test image to test the algorithm based upon the dataset which we have trained and predict the output accurately by this module. Now going to the execution, close this file and go to the code file. This code file consists of dataset files which contains trained data, and this is the model files which have pickle file, .hy file and .npy file. Pickle file is nothing but a serialized data format in the Python used for Python objects. It allows the Python objects into a file and load them back into the memory. Then next one, .hy file. .hy file contains of algorithm information which can be loaded into the project code during runtime to utilize the trained model for various tasks such as making prediction on the new data or performing specific operations. The next module, .npy format. In this format, standard binary files format in NumPy for persisting a simple arbitrary numpy array on disk. The format stores all the shapes and data types information necessary to reconstruct the array correctly, evenly, and another machine with a different architecture. Then this is the sample files used for testing the CNN algorithm, and these are the runbat file. This runbat file, instead of executing the program in command line interface, we created Windows bat file to execute the program. By clicking double tap on it, it leads to the graphical user interface which is interactive to the program user. Now you can see the first button. Click on the first button, upload dataset satellite images using. By clicking this button, you can see the dataset. Select the whole folder and select the folder. Now you can see that dataset is loaded and it was generated the link of the path of the dataset where we have taken. Now click on the button, extract the features from the dataset. By clicking this button, extracting the features from the dataset, it will extract all the features, and also it will generate the features which how many we are found here. Then click on the button, train CNN algorithm. By clicking this button, you can see in the back console the CNN algorithm will be built and it generates the accuracy score of the CNN neural network algorithm for this project. Then click on the accuracy graph. By clicking this accuracy graph, you can see the accuracy and loss graph between the CNN algorithm. So in the x-axis it is found labeled as iterations for the CNN algorithm, and in the y-axis you can see the frequency or the count of the accuracy or loss graph levels. Now in this, blue line indicates the loss and green line indicates the accuracy. The iterations increases, the loss will be decreases and accuracy will be increases. Now close this graphical representation and now click on the last button, upload test image and classify. Now select any one of the image and click on the button. So it will indicates the boxes, red bounding boxes indicates that these are related to the agriculture land. This satellite image was classified as agriculture land. Now close this one and select the one more land for this images. Now click on open. So this all the land was described as urban land. So the satellite image was classified this image as urban land. Now click on the one more image to select the files. Now you can see that satellite image was classified as agricultural lands which was bounded in the red bounding box. Now close this one. In such a format we can execute and we can identify that based upon the satellite image what land it indicates actually. Now close this execution and close the complete running of the code and go to the conclusion. So in this project we have found that prediction of the different types of satellite images classification by using different algorithms. But this system consists of enabled of CNN algorithm with the pre-processing neural network that combines prediction from the CNN network and all with the satellite metadata. So in this project we have concluded that using CNN algorithm with the deep learning CNN algorithm got with the best accuracy score which is in the predicting and also classification of the satellite images.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.